So let's be a little bit more precise, and let's try this out with a specific example right here. And we're going to use this first derivative to help us find the values where this maximum and minimum is going to occur. And we're going to look at the points where we've got a positive and negative value from our derivative right here in order to help us do it. All right, so what do we have to do? First of all, our first job here is going to make the pen work. F prime of x. Let's find our derivative. F prime of x. What is f prime of x? F prime of x, the derivative, we're going to take 3x squared, take its derivative, get 6x minus the derivative of 2x cubed. We subtract 1 from the exponent, move the exponent in front, so 2 times 3, 6x squared. Okay, there it is. So now the next question right here, we want to find out where is f prime of x equal to 0? So we're going to set our derivative, f prime of x equals 0, by setting 6x minus 6x squared equal to 0. A little factoring reveals that 6x times 1 minus x is equal to 0. And so x equals 0 and x equals 1 are two x values at which we're going to have a horizontal tangent. Now the question is, how can we verify, even if we didn't know what this graph looked like, where the function was going to be increasing and decreasing? This is a job for our inequalities. If you recall, at one point we solved inequalities like this. We said, well, where will it increase? It will increase any place where the derivative is greater than 0. So let's take our derivative, 6x minus 6x squared, and find out where that quantity is greater than 0. If you don't recall doing this, this was the kind of inequality where we could set our factors, 6x times 1 minus x, greater than 0, find some points on the number line that make the inequality true, and we know that 0 and 1 are two such points. So we might test, where is this true? Well, we want to pick interval values within each of our intervals. Let's go to -1 back here. What happens at -1? Well, 6 times -1 would be multiplied by 1 minus -1. Is that true? Well, no, right? That makes our derivative negative here, right? We've got a negative value right there. How about between 0 and 1? Let's pick a value like, let's say 1/2. What happens at 1/2? Well, we're going to get 6 times 1/2, which is 3, times 1 minus 1/2, which is 1/2. So 3 times 1/2 is 3.5. Well, that's still a positive number regardless of what actual value we come up with. Then finally, let's go to the right of 1. Let's go out to 2. Let's see what happens. Well, at x equals 2, 6 times 2 would be 12, and 1 minus 2 would be -1. That's a negative value. So our inequality, 6x times 1 minus x is greater than 0, is true over the interval from 0 to 1. So we say that this function increases over the interval from 0 to 1. Okay, not bad. Where does it decrease? Well, luckily I've done most of the work already. I don't have to go through and do it over again. I know that a decrease is going to occur wherever 6x minus the quantity 6x squared is less than 0, and through the same process of plotting these values on the number line, I find that 6x times 1 minus x is less than 0 on intervals where x is less than 0 and where x is greater than 0. So we're going to say that there's a decrease in each of these values. And now if we go over to our graph of the function, which I've helpfully provided on the right, increase, we see exactly what was meant. We've got this decreasing function on the interval from 0 to 1. I'm sorry, from negative infinity to 0. Having a good day. From negative infinity to 0. We certainly see that that's the case. We've got that decrease. And we can see we've got our increase between 0 and 1. And then finally, looks like we've got our decrease back on the interval that goes from 1 to positive infinity. Right? Decrease, increase, decrease. Not only that, but we've also identified where we get our horizontal tangent lines, and that is f prime of 0 and f prime of 1. Recognizing these are where we get those horizontal tangents, what could we say? Well, where the function changes from decreasing to increasing, we have a relative minimum at x equals 0. And where this function changes from increasing to 0 to decreasing, we have our relative maximum. And that relative maximum occurs at the point x equals 1. Well, that's exactly what we were looking for.